Yes, very good morning to all. Myself, Dr. M. Durga Prakash. I'm currently working as an associate professor in SRM University, Andhra Pradesh. So before going to my talk, I would like to share some few things to about this. I'm the alumni of IIT Hyderabad. I'm the first PhD student at Hyderabad in Electrical Engineering Department. I passed out in 2015 in the Electrical Engineering Department in the area of microelectronics and VLSI. So coming to this talk, uh, I would like to present on the title of this talk is Enhanced Temperature Sensing in DNTT-Based Hybrid Dielectric Materials, Organic Thin Film Transistor for Biomedical and Wearable Devices. So this is my outline of this talk. So I'm going to explain about the abstract of this presentation and the introduction, objective, methodology of this work, resultant discussion, conclusion, and references. So coming to the abstract of this paper of this work. So in this work, we have done the effectiveness of DNTT material as a dielectric material with that hybrid dielectric materials, and we have designed and simulated organic thin film transistors using Silvercoat TCAD software as a temperature sensor for the room temperatures, and we have investigated and we have verified the results for two further experimental applications works on that. So in this, basically, I'm going to discuss about the electrical parameters, how the behavior of the devices, and basically, and also the how the sensor is working as a per temperature sensitivity in the range of room temperatures, and the sensitivity range, what range and all we have done in this work. And this particularly this study is highlights the capability of hybrid dielectric materials with OTFT advanced temperature sensing applications. So coming to the introduction of this work, we know that organic thin film transistors are three terminal devices, that is electrical devices that controls the flow of current between two electrodes with the third electrode as a MOSFET devices. And the fundamental building blocks of these devices is basically we are going to use for different applications. Particularly, we have targeted for the flexible and display and integrated circuits as well. And why this organic thin film transistors is important? Because it's the process is very compatible for low temperatures, and it is suitable for flexible and stretchable substrates, and it is enabled for large scale and cost effective productions. With this, the importance of the organic thin film transistor in next few slides, and I'm going to discuss. So the main applications of the sensors is like we have targeted and we are working on for biosensing and environmental monitoring and also variable electronics. So we know that variable electronics like flexible, low power health monitorings and environmental monitoring purpose, particularly like gas detection, humidity, temperature sensings, and particularly there are a wide variety of applications in biosensors, particularly for various biological parameters, biological analytes and all. So this is the for that we have designed and simulated this organic thin film transistors. And what the significance of this hybrid dielectric materials we have, what we have used for these devices is one is hafnium oxide HfO2 as a high dielectric materials. We know that for that is also it is accumulates for the organic thin film transistor for some temperature sensitive, and also the other hybrid materials with the combinations of HfO2 PMMA. These two combinations with the minimizing the surface roughness and interface traps for the degradation of the organic thin film transistors. These two hybrid materials we use it for this organic thin film transistor as a hybrid dielectric materials. And the motivation behind this study is like we know at present we required everywhere, like there are number of temperature sensors we have, but like particularly targeting into accurate temperature monitorings, particularly in healthcare, industrial applications, wearable technologies. So temperature sensor is very, very crucial roles for monitoring, and it's also for high accuracies with that. So we have started work for doing organic thin film transistors in healthcare, particularly diagnosing various types of fevers. So we have started working on various types of fevers like malaria, dengue, and typhoid. All these different types of fevers on single platform sensors in healthcare, particularly using with the organic thin film transist. And in industrial applications related like real-time temperatures monitoring is very, very essential for that high sensitivity. It matters for that industrial applications. We are targeted on other applications, and other applications is like variable technologies. So like integrations into flexible and portable health monitoring devices purpose. And these are the main three areas of applications targeted for organic thin film transistors design function. And this is some brief literature survey, like what we have analyzed. I'm going to skip this literature survey, where there are a number of literature surveys on organic thin film transistors from last to present, like various types of temperature sensors and all. So, and particularly when you are going to work on temperature sensors for this organic thin film, there are a lot of challenges in particularly in room temperatures. So the main challenges here, the reduced thermal sensitivity observed at below approximately at 300 kelvins. So for that, it needs to enhance the performance in the high temperature ranges like above the room temperatures. So for that, we have taken as one of the challenges for designing of temperature sensors with the organic thin film transistor sensors. And the main objective of this work is reduced thermal sensitivity and leveraging with the hybrid dielectric materials, that is HfO2 and PMMA, to high performance with DNTT material, DNTT semiconductor material for getting high sensitivity in the range of at room temperatures like 273 to 300 kelvins. And this is the methodology of work we have started. This is the structure of the schematic structure of the organic thin film transistors with the hybrid dielectric materials. And you can see here the key materials of organic thin film transistors design. One is the DNTT organic semiconductor materials. As we know, that is a high mobility and a thermal stability. With that as a property of DNTT material, we have chosen as a key material. And hybrid dielectric materials, there are a number of dielectric materials we have. So particularly we have chosen here for this room temperatures ranges and all, that is HfO2 and PMMA materials for a smooth surface, reduce the traps and enhance the gate capacitance for low voltage operations and minimize the hysteresis losses. And you can see the structure of the organic thin film transistor is very almost similar to the MOSFET, metal oxide semiconductor field effect transistors, where we have used gate materials and IK inorganic materials, HfO2, and upon that it is low K organic material these both materials as a hybrid dielectric materials, HfO2 and PMMA, and organic thin film organic semiconductors we have used as a DNTT materials. Apart from that is source and drain gates and all. This is the schematic structure of the organic thin film transistors with the hybrid dielectric materials. And this is the work we have simulated using Silvaco Atlas TCAD simulation tool. So this simulation we use it to develop the particularly the top contact, like we have different the modes of operation of the organic thin film with the single gate and double gates, all these things and all. So particularly this model, it is top contact bottom gate, that is TC-BZ DNTT based single gate organic thin film transistor structures we have designed and simulated in using this with these are the parameters what we have used and the materials. So particularly you can see the thickness of the gate materials we have used as aluminum with the 20 nanometers, and thickness of the organic dielectric materials PMMA, that is 3 nanometers. So all the structure dimensions of organic thin film transistors here I mentioned. So, and channel length, it is 10 micrometers and width it is 100 micrometers for the dimensions values. So with this, the methodology we have carried out in the simulation, and the simulation process, with that we have established the structural dimensions and meshing and the common procedures, and we have verified how the device is performing and with the electrical parameters and electrical characteristics of the behavior of the devices. So here you can see the transfer and output characteristics of the DNTT's organic thin film transistors with hybrid dielectric materials, that is HfO2 PMMA. So here you can see the first the transfer characteristics, that is electrical characteristics of the organic thin film transistors. When we are changing the gate voltages from from low voltages to this is particularly this negative gate capacitance with the DNTT single gate materials, and we have observed the drain current behavior of the devices and the range of the drain current. Cursor is not okay. So these are the basic electrical characteristics of the transfer characteristics A, and the second characteristics is the output characteristics of the like what we have understanding and the behavior of the MOSFET. The similar the way we have done the work for the how the behavior of the DNTT organic thin film transistors with the dielectric materials. And with this, we have extracted the parameters of the how we can go ahead with the temperature sensing devices for these parameters, and we have calculated the drain current ranges for the temperatures characteristics for the organic thin film transistors. And particularly the main important thing is here we have to understand about the what voltages the transistor is turning on current and off current, and at what voltages it's required to turn on these devices. Those are the parameters we have extracted, and we have accordingly we have designed and simulated the tools for the room temperatures ranges. That is at 273 to 333 kelvins ranges. And we have observed the sensitivity analysis of the devices for the range of temperatures 273 to 333, and the drain current and mobility of the devices and threshold voltages we have observed, and that is whether it is suitable for different like what we have mentioned about the previous slides applications like wearable applications, healthcare monitor applications. So what range is like the sensitivity is required for that, accordingly we have tuned and we have simulated and modeled the devices, and we have observed the sensitivity analysis of the devices. And finally, the conclusion of this work is that hybrid dielectric materials with the organic thin film transistor as a temperature sensors. The mainly we have targeted that operating range of effectively for room temperatures, that is 273 K to 333 range, and also furtherly enhancing the temperature range for different hybrid electric materials also we have targeted. The key findings here it is high sensitivity and device stabilities, and applications, the continuous health monitoring purpose and environmental medical diagnostics, and integrates with the electronic skin and flexible displays applications. These are the applications we targeted, and next, this is the simulation work we have done, and we are now targeting for the fabrication of the devices. So that's about this work, and these are the references. Thank you for giving this opportunity.